What are you doing?
Jumping.
Why?
To awaken the giant within.
It's working. Okay, we're back. We sort of never left. I don't know whether this is all going to be in one video or it's going to be 2 or 3. I don't know. But this is the 300 WSM bench gun that we had the interchangeable bolt bodies for. Okay, and so last night, which was New Year's Eve, we switched these bolt bodies out and we ran the brass through, and we found out that these bolt bodies, again, if this is a separate video, that's the only reason I'm showing her. This one has an ejector. This one is the one they sent me that doesn't. And I took the measurements off of this one, switched them, ran them in, and they are essentially identical. I would say less than 4 10,000ths. It's somewhere between 2 and 4 10,000ths. Again, I'm doing that by feel, so I can't really measure that. But what was funny is, last night was New Year's Eve, and I was so excited about the fact that these things are interchangeable. I had to talk to someone, right? And so I called Daryl. I have Daryl's cell phone number. I called Daryl up at BAT, and I'm like, Daryl, I switched them, and they're like perfect. And he's like, yeah. And I'm like, you don't understand. I had 8 pieces of brass. It was all numbered. I ran them through, and he's like, yeah. And I'm like, you got to know Daryl. If the building is on fire, Daryl would be like, maybe we should call the fire department. The flames are getting pretty big. I mean, that's the way he is. He's just like, yeah. And I said, did you expect it to be exactly the same? And he's like, yeah. And I'm like, really? And he's like, yep, we see it all the time. So anyways, but that was yesterday, right? But then I realized, and I switched them back, by the way. When I shoot the gun, I'm going to shoot it with the one with the ejector in it. And I'm going to let the customer decide about this. Okay, and by the way, this is look at this. When that was the first time that I had ever switched a bolt body on one of these, and it took us a little bit to get on it. It wasn't super easy, but it wasn't super hard. But the second time, heck, it was a lot easier. So by the time you do it 3 or 4 times, switching bolt bodies would be easy. All right, but I totally forgot last night, because I was totally so absolutely happy with how that turned out. Surprised, really. I didn't think it would be that good. Then I forgot to show you something. This customer requested what I call a stub gauge. Now, like everything, my stub gauges are a little bit above and beyond what most people do. So this gun had a 30-inch blank. This barrel was a 30-inch blank whenever I did it. And I'm not going to take it off and measure it. But right now, this barrel is about 27, where it ended up getting cut. So he had asked for a stub gauge, and I told him if I had enough barrel to do it, and it was the right diameter to do it, I would. And so I went ahead and did it, and it turned out really good. That's why I'm showing this to you. So this piece of metal that's in my hand was the end of this barrel. Okay, that's what that was. And this is important because, and there's no way you're going to be able to see this. By the way, where the heck's my good flashlight? You won't be able to see this, but because it's the actual barrel. Here, I try to look down in there, because it is so cool. All right, that's the top of the lands that you can see down in there. And to be able to hold it in your hand and look at it. I mean, yes, you can look at it with a bore scope, but to be able to hold it and shine a flashlight in there and look at that. Now, again, if you can't see in there, this is a 4-groove barrel. So that means you have a land at 12, 3, 6, and 9. They're opposing each other, right? All right, when that reamer goes in there, there's a taper on that is the throat part of it, where it transitions from the neck into the actual rifling. And it cuts a funnel on it, right? It cuts a funnel on it. And except with the bore scope, you can never see that, right? But when you shine this flashlight in here, you can see that the cuts, can you see in there? The cuts are perfectly square on top of each one of those lands. They are perfectly positioned as far as longitudinally. In other words, when the reamer was in there, this barrel was truly, this piece of barrel, when I chambered this, okay, wait, I better stop. Make sure people understand what a stub gauge is. This is essentially the exact same chamber that is in this gun. I mean, that's the difficulty in making it. The idea is you have this chamber in the gun with the exact same reamer, and you have this stub gauge you made with the exact same reamer, and their head space the same. Okay? And we'll get into that in a second. But one of the advantages of being able to look in there is when this was in the lathe, you know that it was truly spinning on its center axis. It was spinning, and then when the reamer went in there, in other words, everything was right. Because all you got to do is look at the top of those lands and see the cuts on them. Okay? And it looks super cool. The ability to be able to look in there and see that is super cool. And of course, if you turn it around the other way, and again, I don't know if you can, I doubt you can see down in there. I mean, you can just literally look at your chamber, because this is essentially identical to that. All right, now here's the interesting thing. People are like, okay, well, why do you want one of these? All right, here's why. So, look, come over here and look at this. So see, I think he sent me 110, 120 pieces of 300 WSM Norma brass. And boy, I got to stop here for a second and say, holy cow, was this brass high quality. This is some of the best batch of brass I ever worked with. It's so uniform. And I can tell, you know, once I have the gun headspace and everything, I ran all of it. After I did brass prep, I ran all of it in the gun without the firing pin. And so you're feeling it. Right? You're feeling bolt closure. This 100 pieces of brass that are right here is as uniform as I've ever seen. So, I mean, really, really impressive. But anyways, so I did brass work, right? I did brass work to 100 of these. And if you want to see what brass work is, that's, you know, this is bench rest level stuff. Uniform the flash holes, uniform the primer pockets, run a dedicated Sinclair expander through that, trim them to length. Then I turned the necks. Then I ran a Redding neck bushing onto them. Then I retrimmed them. Then I steel wooled them, Q-tipped them, blah, 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 all that stuff. And then I loaded 50. So here's 50 loaded rounds. But I'm using this brass, this prepared brass, to show you something. So, when I headspace that gun, you understand that the brass, the head of the brass, sticks out of the end of the tenon a certain amount, right? A certain amount. And this is something else. If you chamber a lot of guns, even if you use a lot of different receivers, a lot of different cartridges, you're going to find out, because there's standards in all this stuff, that the amount that the head of that brass sticks out of the tendon is actually fairly uniform numbers. It is usually somewhere between 130 thousandths and 150 thousandths. Again, depending on the bolt nose. There's a bunch of things that go into it, but you see those numbers over and over. So this is what a stub gauge is for, though. Okay, essentially you're holding your chamber now in your hand, which makes it so much easier to work with. So this brass is completely prepared, right? Take a piece of brass. Oh, and by the way, this, you know, realize this is a tight neck gun, 337 neck. So if you took a brand new piece of this brass as it came out of the box, it would not go in. It would hit on the neck. In other words, you'd try to push the brass in and it would stick out like that because it's hitting on the neck, right? I turn these. The loaded neck diameter, here, wait, sometimes it's just easier to show people. So this is the loaded ammo. Okay? Look, 336. Now, I'm only running 1 thou clearance, and I'm always getting sidetracked here. 1 thou clearance is pretty tight. Guns generally shoot their best somewhere between 1 thou clearance. Some guns may be 4 thou clearance. In other words, the loaded cartridge is 1 thou smaller, 2 thou smaller, 3 thou smaller, 4 thou smaller. generally in that range somewhere, the gun is going to shoot its best, all right? Again, bench rest shooters know this stuff. Sometimes running it too tight can actually cause flyers, all right? So, and you're going to have to, you'll be like, okay, well, why did you run it so close? Well, this guy's, I think, a fairly knowledgeable shooter, and this is a bench rest gun. And I only loaded 50 of these, and I prepared these so that they'll end up with a loaded neck diameter of 336 also. Remember, 337 in the gun. That is why it's marked on the gun. So you cannot forget that, right? All right. So I turned the necks so that the loaded cartridges are 1 thou under, and that's what I'm going to go out and shoot it at. And I'm expecting this gun to shoot 2/10 of an inch right off the bat, because they do. All right. But let's just say he wants to try to set records. Well, if I would have turned the brass, say, to 4 thou clearance, he can't add it. He can't put brass back, right? But since I only turned it with 1 thou clearance, which is about as tight as I'll run a gun, if he decides he wants more accuracy than whatever the initial accuracy is, he wants to do advanced load work, well, then he can just return them. He can turn them so there's 2 clearance, and he can take out and shoot 50 with 2 thou clearance. He can turn them so there's 3 thou clearance, take them out and shoot them. The idea is, if you start tight, you can keep removing brass, and then you have more options. That's why I did it that way. Okay, now, but that's beside the point. That has nothing to do with the stub gauge. The idea of the stub gauge is that this has to be under 337 to go in the gun. And that's what that measures without a bullet in it. You realize you put a bullet in it, and then it expands, right? Okay, so anyways, drop this in. Now watch. Okay? By the way, you see how it's pushing the air out. You see that? And if there was oil in there, it would just go really, it would be like hydraulic. It would just settle down in there slowly. And this is something else that you can tell. Look how tight this is. Possibly expand radially. Well, look, here's why. You can't move that. There's literally zero movement. Again, I don't take all the credit for this. If Dave Manson didn't make the reamers properly, matched to the brass, you would have slop. But we don't have any slop. Look at this. Now, here's the other thing. You kind of got to listen to this and feel it. So what is stopping this from moving any further forward? And it's really easy. It's the shoulder. Okay? So the shoulder of this brass is engaging the shoulder in what we'll call, I guess, the stub gauge or the chamber, because they're the same thing. All right? And when I chambered this gun, because I built the gun before I built the stub gauge, I got all my measurements, right? And I know that when this piece of brass is sticking out of there, and this should, wow, I hit it dead on. This should be done with a depth mic, okay? Because you realize you can move this around and get all kind of different numbers. But the deal is, and I'm going to show you this, we're going to use this number because it doesn't really matter. We're going to use this number, okay? It's sticking out 130, all right? 130 thousandths, that's sticking out of there. Now, the idea of this is to be able to find your cartridge overall length with the bullet just touching the rifle end. Rather than, and we'll come back to that, you know, normally I do soft seat jam. But when you do soft seat jam, the bullet is jammed. So it can be in there 10 thou, 20 thou, it can be in 30 thou, depending on the shape of the bullet and the angles on your throat, right? In other words, you can push the bullet up in further, more or less. But with this is a great system because you drop this in here, you can hear it. It's up against the shoulder. Now you took a measurement. The measurement is 130. Okay, now what you do is take one of the bullets you're going to use, right? Seat it long. And I don't have just a free bullet here. Seat it long, okay? Right? Seat it so the full diameter of the bullet is only about halfway down into the case, all right? You know, in other words, seat it so that you know it's long, like it's just obviously long. The bullet is sticking way out there, right? Then take your dummy round now that has no powder in it but has a bullet in it and drop it in. Okay, now let's just theoretically say that the bullet is sticking out 100 thou. 100 thou, you have it sticking out. And so you take this and you measure it, and if it's sticking out 100 thou, now you're at 230, right? You're at 0, 230. You got that much sticking out of there. Okay, so this is really easy. Take your, by the way, Harry, you might want to show them that. So this is Reading Type S match die set, and this is a neck die set, right? Okay. Take your seating die, and the reason I'm showing this is because it has a micrometer top on it, right? All right. So you seated the bullet in the case, and you put it in your stub gauge, and you're 100 thou long. Okay, so it's really super easy to verify this. So let's just say you were wherever you were. Say you were like that, all right? All you do is turn the micrometer down 50 thousandths. Turn it down 50 thousandths. By the way, until you know your die, you don't know if these micrometer tops, when you turn it 50, it actually goes 50. But once you get to know your die, you'll know. So turn it down 50 thou. And then you'll be taking your loaded cartridge with a bullet in it, not loaded, no powder, no primer. You'll put it in there. And what happens is if you turned it 50 thou, what would that number be? That would be 180, right?
Yes.
It'll go to 180. Like that. Here, I'll hold that up in a second. Okay? So you understand what I'm doing here. So that's just the brass. This is the brass with a bullet seated long. Okay, you turned your micrometer top 50 thousandths, and now you're at 180. All right, so what you do is again, you're sort of self-checking this process. So this time, let's just say you turn it 20. Turn the micrometer top 20. Take the, and I should be using this for a better visual. Take your dummy round, put it in there, and measure it again. All right, so if you turned it 20, so right now, this should have went to 160, right? In other words, it should be linear. Every single time that you push the bullet, say you push it 20 deeper, what should be happening is it should go 20 deeper into your stub gauge, which is the same as your chamber, okay? So what you do now is you keep going. So say on the next jump, you do the same thing. Here. Say on the next jump, can you see this?
Yes.
Say you take 20 again. So you take minus 20 again, so now you go, say, to 140. All right, now you're getting close, you understand? You're only 10 thousandths off. So the next time, where are you? The next time, what I'll do is I would only take like 0.005. I'd take 5 thou. And so if you take 5 thou on the micrometer top on your die, you should go to 135. In other words, it should still be moving in. All right? On the next one, I would only take like 0.002, something like that. And so it should go to 35, 34, it would go to 133, right? So you're checking yourself as you come up. Now, when you go, say you go 2 more, and it should take you to 131, right? 131. It still moved in. You took 2 on the thing, and it moved in 2. All right. The next time, you only take 1. You take 1 thou and see if it goes back to 130, which was your original measurement. If it does, okay, then you know that the bullet is just touching the lands. And it's, if you want to mess up, I usually quit right there because I've done this a million times. But if you want to mess up your dummy, then all you got to do to double check it is, triple check it, is take 2 more thou. If you take 2 more thou, and this number does not change, because now you realize you're back to your original number where the shoulder of the case is hitting the shoulder of your stub gauge, then you know now the bullet's 2 thou off. So it's a really, really easy way to establish your cartridge overall length to have the bullet just touching the lands. All right, now I want to show you something. So, and by the way, you almost have to have a micrometer top on your cedar die to really do that well. But I want to show you something here. So, when I did this, I did it with the stub gauge first. In other words, when I was actually going to load for this gun. And the measurements I got, when I did it for the stub gauge, I built 3 dummies. Here they are right here. These are the actual dummies. And and we'll just use the cartridge overall length, because this is off of my comparator. But I got 3.132, 3.131, 3.139. Now you realize when you're measuring cartridge overall length, you're going off the tip of the bullet, right? So there's going to be some variance right there. All right, so I did that. And then, of course, I checked with my comparator. And you can see the numbers, you know, they're fairly uniform. Then what I did is I did my normal process, my soft seat jam. And what that means is I take prepared brass. I actually put a little bit of sizing die wax on the bullet itself, around the base of the bullet, and then I seat them long. You know, and usually I seat them 50, 60, 70 thou long. Take the firing pin out of the gun. Again, I've showed this on other videos. Stand the gun vertical, set the cartridge in, close the bolt. You will feel it push the bullet back down into the case. And so these are the numbers I got there. Okay, so look. 32, 52, 31, 53, 39, 53. And again, obviously that's an outlier for some reason. We don't know what. Probably just the tip of the bullet. So it's really easy to see here that when you're doing soft seat jam, at least with this gun, because different guns are different, that the soft seat jam was pushing the bullet in the rifling about 20 thousandths. So it's a really cool system because you have this to do it initially just to find where the bullet is just touching the lands. And then you go back to your regular system and double check it because you know when you push it in, it's pushing the bullet in the lands. That's why they stick sometimes, okay? Although they generally don't stick on a foregroove. That's a whole other subject. Then what you end up with is, look, so they can see. So you end up with 3 stub gauge dummies. You end up with 3 actual soft seat jam dummies, and then I always give the customer a couple pieces of prepared brass also, so that they can take all the measurements off of that. And so anyways, that's the whole point of a stub gauge. I mean, they're really cool. Now again, I can't make one for every gun, depending on the diameter of the barrel. No, I shouldn't say that. I can't make one for every gun out of the actual piece of barrel, unless the barrel is long enough and it's big enough in diameter. Okay, so you can't do that. Now you could make them out of scrap, but again, I don't want to go too deep here, but you realize that barrels, like right here, we write down what the barrel actually measures. And in this gun, it actually measures .300 by .308. All right, not all 30 caliber barrels measure that. I mean, it could be .2995, and it could be 3075. So the internal dimensions change. That is going to change where the bullet hits the rifling and how far it goes into it, how it engages it. So, okay, I want to quit. You can make a stub gauge if the barrel is long enough, you have enough extra, and you have the right diameter. It has to be big enough to do it radially, right? This measures 1 inch, by the way, which is exactly what he asked for. So you can do that. If you can also make a stub gauge out of a piece of scrap, and it'll get you close, but it won't get you exact. So my whole deal with this is, essentially what you're holding in your hand here is identical. You know, remember, nothing's identical, but within a few 10,000ths of the exact chamber in the gun. So you're holding the chamber in your hand, you got one here, you can compare everything, and you can see how uniform it was. I mean, it's really cool. So anyways, I wanted to show you what a stub gauge is and what they're used for. See you later.